Hello, everyone, and thank you for joining us for today's climate action webinar, Designing for Zero Net Carbon, 3 case studies of all electric buildings. I'm Bill Burke, AIA, and I'll be your moderator for today's webinar. Some of you may know me. I'm an architect with many years of experience in low environmental impact, zero net energy, low greenhouse gas emissions building design. My focus for the past 25 years was on educating students and design professionals to improve building performance. And for 20 years, I organized educational programs targeting design professionals, builders, and policymakers at PG&E's Pacific Energy Center in San Francisco. So I retired from PG&E in 2020, but I continue to work on education and policy initiatives through AIA California's Climate Action Committee. Okay, enough about me. AIA California recognizes that the planet is experiencing an urgent climate emergency and that California should continue to elevate its position as a global leader in addressing the grave challenges of advancing climate change. To help do this, AIA California has developed an in-depth educational climate action webinar series that incorporates the AIA's framework for design excellence and includes zero net carbon design education. So to qualify for continuing education credit, AIA-CA provides the learning objectives for every webinar and includes them in the PDF presentation that will be made available online. Today's session also qualifies for zero net carbon mandatory continuing education, a new requirement from the California Architects Board for license renewal starting next year. A certificate of completion will be provided to those of you who stay on and complete today's webinar. Okay, a few housekeeping reminders. So this session is being recorded. It'll be posted on the AIA website, www.aiacalifornia.org, with some additional resources shortly after today's session. That can mean a couple of days. So if won't be up an hour after the session, but pretty soon. So you'll be able to see that. Today's session qualifies for 1.5 AIA Health Safety Welfare Learning Units for those watching live, and AIA California staff will report those units for you. So just a couple of more things, please use the Q&A function to ask questions for today's presentation. You can also like a question to move it to the top of the queue. The questions that we don't get to, if we don't get to all of them today, we'll answer them on the website after the program. Okay, so today's program, as I mentioned, is Designing for Zero Net Carbon, 3 case studies of all electric buildings. So this program will review the design strategies for 3 common building types designed as all electric buildings, discuss the readily available all electric building systems utilized by the design teams, and present measured post-occupancy performance data that supports the achievement of zero net energy and zero net operational carbon. Today's program will discuss tools, metrics, and modeling used in pursuit of the performance goals, and will highlight exemplary features of the various projects, discuss problems encountered and lessons learned that can help other practitioners achieve similar levels of performance in their own projects. Before I introduce Ed Dean, our presenter, I do want to mention, put your questions into the Q&A, not the chat window. And then Ed is going to do 3 case studies. So the way we're going to aim this is at the end of each study, we'll make an effort to basically take a break, and I will bring the questions that have been typed into the chat, into the Q&A window to Ed's attention, and we'll make an effort to address questions for each building before we go. But you can continue to type in questions if after we move to the second case study about the first project, if they come to mind, and we'll get to those at the end of the entire webinar. So, okay, with that, I'd now like to introduce today's speaker, Edward Dean. He's a fellow of the American Institute of Architects. Ed's a combination of building scientist, design coach, and experienced large project architect. who has specialized in low energy building design throughout his professional career. In recognition of his professional work in the field, the AIA elevated him to the AIA College of Fellows. He was initially trained as an applied scientist, receiving a PhD from UC Berkeley, but quickly switched to architecture to focus his work on the design of the built environment and the emerging need for low energy building design. While on the faculty of the Department of Architecture at UC Berkeley, he consulted with the California Energy Commission on new energy standards for buildings, worked with Lawrence Berkeley National Laboratory at the beginning of their energy efficient buildings program, and led a generation of architects through concepts of integrated design for low energy performance. In his architectural practice, he led the design team for the early zero net energy all electric West Berkeley branch library and his own zero carbon house. He's authored 6 books, which you see here on this slide, documenting case studies on zero net energy and zero carbon buildings, all commissioned by utility companies in California under the sponsorship of the CPUC. So the first 3 were with PG through PG&E, and the more recent ones are with Southern California Edison. So with that, I'm going to step away and take it away, Ed.
Thanks, Phil. I'm going to share my screen and start the slideshow. Okay, there it is. So we're going to do 3 case studies that were in this last book, just printed out, just available through Southern California Edison. I guess the links for all the books are going to be presented after this webinar. Bill will maybe come in and tell you how to get them. They're available free of charge for download on the website, so there's going to be a link for that. But this last book has been focused more on case studies of recently completed buildings that are designed as all electric and therefore will be zero carbon when California switches the grid to or becomes totally transformed to totally renewable energy and non-carbon sources. So at that time, which is scheduled currently for the year 2045, when that occurs, these buildings will all be zero carbon. So that's why the title for the book is Designing for Zero Carbon, because we're going there. And these are great examples. We sifted through something like 30 case studies, 30 candidate buildings, and came up with the 5 in here, which were chosen because they're more or less typical of buildings that most architects and engineers deal with. An office building, particularly a speculative office building, public school, a middle school, a lot of offices do schoolwork, a college classroom, an office building, but this one is going to be interesting because, and it was selected because it was a renovation, and there was a very comprehensive study of embodied carbon for this project, and that is now emerging as one of the important issues to look at and get and discuss. And I'm glad that we got one in this particular book. So these are the 3 we're going to cover. Let's start with the spec office building. And oh, by the way, let me back up just a little bit. I'm going to try to make all the structure of these 3 presentations, these 3 case studies, the same, and so that you know where we are in the presentation. We're going to give you some background to the project and the zero carbon design strategies in particular that were employed for this building type, and this building in particular. Then the renewable energy sources for the building. These buildings were focused also on zero net energy performance, very much so, but zero carbon design, we like to see a lot of energy efficiency for those buildings, it doesn't necessarily have the zero energy, zero net energy, but it should be very low energy. And we think of approaching, sorry, my trigger finger is a little quick here. And then the energy performance analysis, these buildings are modeled for energy performance. And in the case of the renovation, a detailed carbon analysis was done, and we're going to show you that. And then as we'd like to look at each one and ask the designers if you could do it again, the project again, because you're not going to get that chance, but if you, what is there about the project that you learned? And is there something that you can pass on to other designers as they set about doing similar projects? So we think that's an important thing to talk about. And we'll get to that as the last subject item. So that's the outline for each case study. And we'll get started with the first case study. This is the spec office building. It's a new building. It is located in San Diego. Very, very benign climate, kind of the perfect climate, if you will. You can see here it's 6 stories. It has commercial rented space, tenant space on the first floor, and 5 stories of tenant space on the upper levels. And let's look at what the key background, project background information is for this project. So it was a new 6-story spec office building. Has tenants that lease. That's always a challenge. Tenants don't tend to be conscious about how much energy they're using, although this project did attract some tenants that were very interested in the energy features and the energy efficient features. The client in this case was a joint venture developer team, not unusual. The managing partner was Langford and Associates, and they were awarded the contract by the owner of the property to develop this whole 6-block area, which was known as Maker's Quarter. It's kind of south of downtown San Diego, and the Block D project. This one, so it's called Maker's Quarter Block D. Is the name of the project. It is one of the 6 blocks that are going to be developed and are being developed at this time. And the project goals were stated. You have to good to state them at the beginning so you can make all your design decisions accordingly. It was to be 0 carbon in operation, so all electric building. And they targeted 0 net energy performance. Now, this competition for the project, which was won by Langford and Associates and that developer team, the competition was in 2014, and the project was completed in July of 2018. So that's the time period that we're talking about here. So the 0 net energy performance goal was definitely for the core and shell. And those of you who spec office buildings know that what part of the building that is. And as much as possible for the 10 spaces also. Sorry about the fast trigger here. They wanted to get it certified by the International Living Future Institute, better known as ILFI, and they weren't going after a LEED Platinum certification. This LEED Platinum certification, it turns out, was important in helping the developers secure funding. I'll get to that a little bit in a minute here, but it was a very positive thing and helped in that regard. The program is about 10,000 square feet per floor. So it's 10,000 square feet of ground level retail and 10,000 square feet of each floor tenant space in the whole building. So it's a big building. Trying to make something like that 0 net energy was a challenge. The project location, as I mentioned, was San Diego. So the benefit there is a good climate. Anyone who knows San Diego realizes you can do a lot with the design strategies, and let's get into that a little bit. I want to mention, that the design team was BNIM Architects of San Diego, and the mechanical engineers were Siska and Hennessy of San Diego. They were with the developing team, and they designed the scheme which became the winning scheme. So kudos to them, and want to make sure I mention them. Here's the site vicinity map. You can see here on the right, this, I'm going to use my cursor somewhat. The outlined in red is the so-called Maker's Quarter. This background of this project is quite interesting. Is this land was owned by the Navarro family. They accumulated the land after World War II over a period of time, and it was kind of the artists section where the shops to fabricate various things were in place. So it was away from downtown, but serving downtown. And a lot of these shops were so-called maker shops. That's where the name Maker's Quarter came from. And there was even a professional boxing venue within this area. So it's kind of interesting, its history. So the family is going to renovate this whole area. You can see the scheme on the left, and circled in yellow is the project, the Maker's Quarter Block D project. And this is the one we're looking at. You can see the future development of this area. It's really going to be built up with condos and commercial and a lot of park space. It's going to be a very nice part of town eventually. There is gas in the street, but the decision was made not to use it. They want to make an all-electric building, and so that zero carbon was definitely the design goal in this case. Let's see, there was originally first a housing project, and then came the Block D office project. So that was only the second project in the area. And I mentioned the zero carbon golds and the elite platinum helped them get the initial funding because the Navarro family retained ownership of the land. And so this was a project with a ground lease. The developer was building on the land owned by the Navarro family. And apparently, those of you who know development financing, it's a little harder to get financing with that, but they found lenders who were very favorable to the goals of the project. So just saying the goals of project can help out with the nuts and bolts of financing. Let's look at the design strategies. I mentioned San Diego's got a great climate, very benign, so you can do things like natural ventilation. It's very much the major design strategy for this building. And you can see on the left, there are these, and in the photo, there are these large garage doors that pull up and allow air to flow through the building for natural ventilation, and it vents out on, this is the west side, and it vents out on the east side. The direction comes from where the ocean breezes are. And the corridors around, the corridor in service to the outside is part of the core and shell. And it turns out that the San Diego Planning Code does not count outdoor balconies as assignable space. So they were allowed to build more more assignable space in the building by making these outdoor balconies and designing them in such a way that they can be incorporated with the indoor space. So it's an indoor-outdoor kind of tenant space. So that was a very positive idea that they took advantage of. And of course, they played right into the strategy of natural ventilation. The control system integrates a garage door and all the window openings with heating and cooling systems. So the system won't operate for heating and cooling if the windows or the garage door is open. And conversely, the control system opens the windows for natural ventilation and shuts off the heating and cooling when the outdoor air conditions are determined to be adequate or good for natural ventilation. So it works both ways. And the tenants had to be tuned into this kind of operation in order to properly control and understand how the space should be used. And there's also manually ventilated, manually operated ceiling fans. So you can, if the things close because it's getting colder outside or something, if the garage doors go down, the windows close and the heating comes on, you can still have air movement that can augment it. Or if the temperature is getting up a little bit, the ceiling fans can help keep you cool while the air is on the warm end of the spectrum. So you can do fine control of temperature, keep the space comfortable through manipulation of the ceiling fans. So that's a nice feature. And as I mentioned, the tenants have to be aware of these things. So they're given information about it and shown how the system all operates, but the leases themselves also explain the operation of the system. So there's no mistaking about it. They often read that very carefully. And that any tenant improvement has to be reviewed by the owner to ensure that nothing will counteract the operations of these systems. So they're very nice ideas, but you really have to make sure that the tenants include into them. So sun control, you might have noticed in the early picture of the building, these nice movable sunscreens on the west side. They are in fact, you can move in any position you want. So if a tenant is using some of the outdoor space for office space, they can move the sunscreens and protect from sun when the sun comes around on this side. It also shades the glass, obviously. And on the south side, which you see on the right side of the slide, there is automatic blinds so that the south facade of the narrower facade of the building, but the sun is very different on this side and can be controlled quite well through the use of automatically adjustable blinds. So that's in place on the south side. And it's good for daylighting at that end of the building because by tilting the shades, you see a little sunlight coming in here, but you can keep direct sun out and maximize the amount of daylight that's penetrating to this end of the building. So daylighting is a factor, and I'm just showing this control system. You might imagine it's somewhat involved with the BMS, so that as I mentioned, when the windows are open, the heating and cooling system can't operate and wasting energy. And similarly, if outdoor conditions tell you they can use the outdoor air, they open the windows automatically and shut the system off. So there is a control system operation of the building, which is fairly sophisticated. Also, mechanical cooling, of course, is hardly ever needed in San Diego at this climate. But for the entire building, there's one heat pump with a multi-zone fan coil units connected to variable refrigerant flow lines. So multi-zone fan coil connected with VRF lines. And each floor has, in addition, its own DOAS unit that is dedicated outdoor air supply. So this is a very efficient all-electric system working in the building. There's an energy recovery heat exchanger also that gets the heat exchange between the incoming air and the outgoing air that squeezes a little more energy out of the air, so it's got that kind of sophisticated HVAC system. Lastly, it's, of course, if it's all electric, it's going to have kitchens in the office that are going to have to be all electric. So there's induction cooking. It works very well. And interestingly, the client is getting apparently a new client, a new commercial client at the ground floor is going to be a bakery. So it's going to be interesting if they make an all-electric commercial kitchen for the bakery. Next time you're in San Diego, visit the building and check it out. You might get some croissants while you're at it. So let's look at the renewable energy system here. We have on-site solar voltaics. They're all on the roof. And the idea, of course, was to make it zero energy. So you can imagine that with everything on the roof and the mechanical equipment up there, they had to mount some of the solar panels above the mechanical equipment. And also you can see here on the west side, some of the panels are overlapping the parapet to get enough solar panels. So there's a total of almost 64 kilowatts of standard panels and these bifacial panels, which are collecting more energy because they're collecting from both sides. And they're the kind that's overhanging here on the west side. There's 50 kilowatts produced by those panels. And let's take a look. Here's a visual look of what it appears to be when you're looking up at the building. Quite interesting, actually. The model EUI was 29.2 and measured is 14. Now the funny thing is that there was data only collected for the time that the tenants first moved in. So we have a kind of under demand for this period. So it's more than, it's net positive, but they had a low demand here. The loads that they're experiencing in the current time is more like here on the right. But you can see that it's going to be less than that model when it was modeled to produce zero net energy. So it is a zero net energy performing building with that rooftop array. And here's a complicated looking graph, but the tenant occupancy in August of 2019, of course, with all of these three projects, the pandemic coming in between disrupted a lot of occupancy for both the commercial and the school project and so on. So it's going to affect the data a little bit. But you can see here the dotted graph is the energy use for the whole building. And the energy use for the tenant area is this darker line. And so the core and shell is the difference between the two here. So the tenant is using most of the energy, not surprising. And the energy production for the whole building is the red line. And then you can see it's more than the energy use in the core and shell area. So it's basically they're meeting their goal of being net positive for the common area or the core and shell area. But if you count the energy being used by all the tenants, it's not possible for it to be net zero. But as I say, it's okay for the building to not quite be net zero or not be net zero if it's zero carbon performing. And it will be that in like at least by no later than 2045. So it's a really good example from that point of view. Watching the time here. So did they meet their goals? Yes, the carbon goals were achieved and they got zero any performance for the common areas or core and shell areas. The developer says, yes, our financial goals were appeared. They made the right kind of profit that they were looking for. And with all these zero carbon and energy efficiency features, and as I said, the energy efficiency, the LEED certification and ILFI certification helped them with getting financing. The commissioning challenges, they were harder than the normal building. That is kind of the no-think building. This was a sophisticated building, and there were going to be commissioning challenges, but they met all of them. Everything is working well now. They did not do an embodied carbon assessment for this project at the time. That wasn't a priority, and also the tools are not as developed as they are now. But the project team says in the future they're going to do this in future projects in the Makers Quarter and also in their own future projects. So I'm going to stop here because this is the end of the case study. If you want to read much more detail about this project, get a free copy of the book from where you can download it online and read about it in detail. It's a really great project. Bill,
we have some questions, Ed, so let's get to them. And I will mention, a number of people have asked how you download these, and I did put that in the Q&A, but also we'll be sending the links to everyone afterwards. So, you know, if you can't get it in the Q&A, you can relax. We'll be sure to get you the links so you can get all these. So there are a couple of general areas. So Ed, let's talk initially about some of the shading. So one person asks whether the shading on the south side is interior or exterior.
It was exterior.
Okay.
Exterior
and then a related question is, someone points out that the sliding sunshades on the west side don't seem to be able to cover the entire facade. So how does that work, both, I think, from an occupant perspective and from a load control perspective?
You know, it's interesting. I love to visit these projects as I'm writing about them. And it's actually my intention to get down there in about a month and walk through the building. I'll be able to answer that question better. But at the time, we had the pandemic intervening when these case studies were being put together, and I couldn't visit the building. And that's one of the things that I would see, obviously, and I'd ask the same question. It's the same question I had in mind when I looked at it. So I suspect, I don't know, I have to see that the tenants put up shades of some kind on the inside. That would be something I would have to ask the architects about. If anyone from BNIM is in this call, maybe you can type it into the chat box and answer the question directly. They would know. Okay, great, thank you.
A couple of other questions really have to do with the natural ventilation strategy. So I'll run through, you know, a couple of them, and then you can try and address them all. So, you know, one person asked, how do you control dust, debris, birds, for example, when the garage doors are opened? Other people are asking, you know, how do you balance outdoor sound control and air, you know, is temperature the only factor controlling the open-close function on the facade? And then, you know, another person asks, is there individual control for the doors and windows, kind of related to that issue of sound? Is there traffic noise coming from a freeway, you know? So kind of just making the point that acoustics are kind of a big issue in an office environment. So do you know yet sort of how that's being dealt with?
You know, those are all really good questions. I cannot answer them definitively. I wish I could say stay tuned, or there was some way to communicate the answers. Again, maybe if someone from BNIM is on this webinar, they could type in the answers to those. I would assume, just by looking at the photos, not having visited the project, that all those things happen with buildings. And it's not a dense part of downtown, although it may be in the future. It may become a very active part with horns blowing in the street and so on and so forth. and birds. Although I personally think that wouldn't be too bad. It's not nesting inside anyway. I'm just guessing. Yes, all those environmental factors, in addition to air, are going to impact the space. Perhaps the tenants decide to keep the garage doors closed and the windows or something, and just have the the windows can be operating without worry. Every natural ventilation scheme is going to have outside noise issues. So
Are there any screens? So if the garage doors are up, is it possible to, basically keep a bird from flying in? Do you know that?
I do not know that. I'm sorry.
Okay.
Yeah.
All right. So then, sort of related to that, I think someone asked if what happens if the electric power goes out, and I think they were asking, like, and the garage doors are up. Can you, in an emergency situation, I guess, open or close the garage doors manually? And
I would, yeah, I'm not, again, I don't definitively know the answer, not being the building designer, but I would assume that there's manual override is possible.
Yeah, okay. Let's see, someone asked a few more. Someone asked if you could briefly describe the bifacial solar panels. Does the backside collect reflected light?
Yes, I mean, the light is incident on both sides of the panel, and there are, the thing that light strikes to get into the physics of a solar panel is they're on both sides. So it's collecting energy on both sides just because it's facing that direction. So it's reflected light, and also, well, probably reflected light because it's coming from below. It wouldn't have this direct sun. There's an example in one of the other books, in the residential books, of a condo development that had these bifacial panels on the roof. Same problem. There were 4 units stacked up, and the only place to put the panels was on the roof. And they used bifacial panels and they did manage to make it a net zero. Because there's not quite doubling, because the light from below is not as strong as the light from above, but it's collecting much more energy than just a single-sided panel.
Okay, let's see.
Should I get into I'm worried a little bit about time. Should I?
Okay, then why don't we say, we're saving these questions. If we can get to some of them at the end, maybe it's time that you go on to the second case study, and we'll come back to these if we are able to. Okay,
good. Yeah, let me, I now have a sense of how long it's going to take.
Okay.
So this is the school example for those designing schools. It's a public school, so it's done under, this is the San Francisco Unified School District. It's a middle school, sorry. So the buildings program was passed as a proposition in the city, and there was over $500 million worth of bonds for school construction passed. This was in 2011. It takes a while to get these programs going. As a result, the school district developed design standards for zero net energy performance for different types of school buildings. And they wanted to push these standards into the new building projects. Through energy modeling, they were able to establish goals for the EUI and the calculated size of the PV system necessary to make it zero net energy. And they put this into the standards, and they rolled out the standards for the projects of this Proposition A. This project was a middle school project that they did as kind of the first project, although it wasn't paid for by the proposition funds. They did apply the design standard to it. So it was only a 2-story, 12,000 square foot all classrooms and one gymnasium on an existing grade school campus. And you can see its location here. It's in the Marina District of San Francisco, so it's a low-rise urban setting. New building is circled, and I'll show you the site plan. So the new building was built down here on a part of the play yard. The existing building was a 1930s classic public school building. And when they needed space for middle school grades, they put all these bungalows in. This was kind of the standard way of dealing with the need for space in California. So a lot of these temporary buildings were in place, and the proposition allowed San Francisco to demolish these bungalows after they built a new building to house these growing programs. So you can see it's on the south side of the block. So there were meetings with the neighbors, because in San Francisco Bay Area, neighbors get involved in any building project. And so the idea of putting a building up across the street, and some of these houses overlooked, had a bay view from their houses. They could look across the school property to see the bay. And they did not want this new building to block their views. So they reached an agreement with the school district that the roof would not even have HVAC equipment on it. And even though it's legal in California to put solar PV panels on the roof, they made an agreement that they would not put the PV panels blocking the roof, or be put on the roof near the street. So with that agreement in place, they went ahead and they realized that the energy production, excuse me, let me go back to this slide again. If they could not use the roof on the street for solar panels, the amount of solar panels which would be on the backside of the building and on the gymnasium, backside of the gymnasium roof, that'd only be about 2/3 or 1/2 the solar panels necessary, as by calculation according to the design standards, to make the building zero net energy. And so the design team was challenged to make the loads lower than design standards called for, in order to make it zero net energy. So they had that challenge in front of them. And by the way, I failed to mention, I want to make sure I do this. The design team was, the architects were Lionakis of Oakland, and the mechanical engineers were Capital Engineering Consultants, their Alameda office. So that design team was faced with making even lower energy loads in order to make the PV system produce enough power to enough energy to make it zero net energy over the course of a year. And things intervene, including the pandemic. So let's get into that a little bit. So the designed strategies. The first one is the obvious one, a building envelope insulation. The windows are designed such to, like the old-fashioned schools of the 1950s, were designed with a lot of windows for daylighting and air ventilation and so on. So they're reverting to this approach. The walls are not overly done, but they made sure that that there would be not bridging of the energy, the heat energy, of the metal studs that are used in the framing. So they applied rigid insulation over the outside of metal studs that prevented thermal bridging from occurring. So they took that extra step, cost a little more money, but it made a better performing wall. And the roof is made heavily insulated, or R31. The windows are double glazed and with a good solar heat gain coefficient. for reflecting the energy that will, and there's no cooling applied here, it's only heating. So there is not this wasn't a critical factor, but it was specified as part of the window. On the windows facing the street, there is a sun control over the windows, and in the gymnasium, there are two clear stories on each side of the gym, and there is some additional natural solar tube skylights, and so it's all naturally lit and somewhat glare-free, so that works well for the daylighting. Notice in this, the building was had to hug the street line as part of the agreement with the neighbors about how the building would be massed and so forth. But let's look at that. Well, let me cut. The heating system is kind of a standard electric heat pump with VRF and the fan coil units in each classroom. And the gym has a roof-mounted VAV heat pump package, but that's on the far end of the roof, and that does not interfere with the agreement made with the neighbors. Oops, sorry. And then the domestic hot water was a standard electric resistance water system. So some things are pretty standard in this building. Here you see the only 3 areas that they were allowed to put the solar panels, including this end of the gymnasium roof. They were permitted to put the solar panels, but over the other wing of the classroom building, they had to, sorry about this. They had to put a conventional roof that matched the existing old building roof. And this was a concession to the neighbors, but they had fewer solar panels and were getting only 82 kilowatt hours. And the annual PV production was modeled at 13.4 kBTUs per square foot. But so it turned out that they modeled the school building. They got the same, for modeling, the same number, EUI, so it did look like it was on track to make a zero net energy performer out of it. So the EUI for the loads was equal to the amount of solar that would be collected on the cutback size of the PV arrays. So now I have to explain what happened. They did not get the solar panels. In fact, they're going to be installing, or maybe in the process of installing, these solar panels this year. The pandemic intervened, classes were suspended at school. A lot of things went on that they couldn't do it. So the way that the EUI, they did get 1 year of data before they shut down for the pandemic. But it turns out that they forgot that the meter was going to be on both buildings, both the existing and the new building. And so the 1 year of data was only, the combined total. It wasn't for just the new building. And so I had to do a calculation for the book. So I was given the energy that was used by the existing building when the existing building was alone. And they had 5 years of data for that existing building. And so by averaging the amount of energy used each month for that existing building, I was able to get a number for the average year. And then for the 1 year of data that they had for the two buildings together, by subtracting out the average of the existing building, I got a very approximate number for what the new building did by itself for that first year before they shut down for the pandemic. So that's a long-winded explanation. This black line is the electric energy use, and the EUI was actually 16.7, which is pretty good. And when they get 1 year of data, now the school is returned, they've been back to school again, and they've almost collected 1 year of data. We'll see how, if that number is getting down to the 13.4 that they expect or not. Also, the PV system was not installed and is only now being a third-party PPAs, as they say, is going to be installing the system. This is a modeled energy production number using PV watts. Those of you who are in the energy business know what that means, but excuse me if I don't go into it. Anyway, it's not quite, according to these very rough approximations, it's not quite, it's net negative. It's not quite net zero yet, but it looks promising when the actual solar system goes in and we get actual data that it will be net zero. But again, it's all electric, so therefore it's going to be zero carbon in 20 years. And that's the big headline story for this. Oh, by the way, in case anybody's wondering, the cumulative net energy performance, I once learned what this was, and I liked it very much from John Henry of the Intergroup Group. What you do is take the difference between the energy you produce and the energy used by the building. And if you use more energy than produced that month, it's going to be a negative number. But if you're producing more energy than you're using, it's a positive number. So each month you add the total up and accumulate it, and it should be zero at the end of the year if your building is operating at zero net energy. That, in a nutshell, is the explanation of what cumulative net energy performance means. And for me, the picture, the reason I like it is that the picture gives you a net negative performance or net positive or net zero, but most buildings are either net positive or net negative, and you see this in one picture, so I like to use this. So quick post-occupancy, we're back on track in terms of time. So will the Project Carbon goals achieved? Well, we don't know. The pandemic intervened. As I mentioned, the solar PV system is being or is about to be installed. I have to check that with SFUSD. And the data collection is now underway. So we'll see very soon whether the Project Carbon goals are achieved, and if not, what they may do about it. Again, our embodied carbon assessment wasn't done at the time because the building was occupied in 2019. Again, the analytical tools are only now becoming folded into Revit program as a Revit software as a routine thing. So it can now be done, but it could not necessarily be done at the time. SFUSD says it's going to include this embodied carbon assessment in the district design standards going forward. So we're on the edge of something that's going to be good and people are going to follow it. So if I didn't rush too much, Bill, we can take questions on this school project.
Sure. And so first, one question is, and you may have mentioned this, who are the MEP engineers? You mentioned Leonakis was the architect.
Yeah. So it was Capital Engineering Consultants. They have an office in Alameda. I think their main office is Sacramento. Okay.
Are there batteries?
No, they don't. None of these projects have batteries at the current time that I'm aware of. Anyway,
yeah.
Maybe retrofitting something.
Okay, so basically, if you overproduce the PV, I mean, this is part of the whole thing of if you overproduce, you get a credit on your bill, which is then applied to the times when you're drawing off, when you're producing less than the building is drawing, which could happen either in the evening or likely in the winter. So I believe, and you may or may not know this, Ed, but 2022 Title 24 that kicks in January 1 of next year begins to have prescriptive requirements for batteries in non-residential buildings. We've had them for residential new construction, single-family residential new construction, or actually I should say low-rise residential new construction since January 1, 2020. Okay, let's see.
So can I ask a question, Bill? Since
Sure.
you know a lot about it, and I was not aware of this. So if you're building a house, you have to include a battery, a certain amount of battery, or
I'm sorry. I think that's also in 2022. My mistake. Thank you for correcting me on that. The requirement that kicked in for low-rise residential was for solar, and so we are not batteries. So I think in 2022, honestly, I'm sorry for confusing people. I'm not sure what the low-rise residential requirement is for 2022, but I know there are some requirements for battery storage in non-residential. The best place to look for that, and again, I apologize for creating any confusion, is to go to Energy Code ACE. And if you just type in Energy Code ACE, you'll see they have tremendous amount of written and webinars on current Title 24, and they're doing things on 2022 Title 24 as we speak. So sorry for confusing that.
yeah, that's right. That's interesting.
Yeah. So one person asked, do you know the budget of the project? And the follow-up question to that is that someone said that you mentioned that there was a bond measure that was passed, but that this project didn't use those funds. So
Yeah, it's my understanding that this was like a pilot project. It uses the design standards developed for the projects. It was Proposition A, passed in 2011, and the school buildings using those funds are required to follow these design standards. And they tested it out using on this one project. But this one project was built using on the funds, is my understanding.
Okay. Someone is asking, is daylight savings time beneficial to projects with PV and in particular a school?
So somebody is thinking about the pending legislation about daylight savings time.
Yeah.
I mean, your guess is as good as mine. I'm thinking just when I think it through, 1 more hour. They don't shut off the solar system, and it takes a while for it to get going in the morning.
Yeah. Yeah. Okay. So
I don't know.
You're going to have the same number of hours of sunlight for the system. It may play into a given rate schedule. I mean, the rates go up at 4. Peak rate is now 4 to 9 for most time use systems. One thing I think that daylight savings time does potentially do for schools is, particularly if you have west-facing windows in an elementary. In many schools, if you're if the school day for students is ending at 3 p.m., it means you're actually ending at 2 p.m. solar time, and thus loads from the west are less of an issue in a school, potentially as a result of daylight savings time. But that's probably a discussion for another webinar.
I guess the batteries come into that discussion too, because if you're storing, you can tamp down your load a little bit. But I'm just thinking when I should not be talking.
Okay.
Thinking out loud.
Yeah. I think that's it for questions on this project. There are a lot of questions that we have not gotten to but I think you can probably go ahead with the next case study, Ed, and we'll come back to
Okay.
these if we can.
Okay, I would just say again, you can read a lot more detail in the publication. And by the way, it has 5 buildings in the publication, so you get 2 other projects to look at. So I recommend downloading that file. Okay, so this one's really interesting. This is the college, I call it the college classroom office building, classroom and office building. It's a renovation, but this is a really interesting project at one of the Claremont colleges in Southern California. So it's a renovation of a building that was essentially abandoned in the 1970s. I'll get into that in a little bit. It used to be, was first built as a student infirmary. And again, I'll get into history a little bit. The renovation of that structure into a college classroom building. You saw the image of what it looks like, going back to this slide. There it is in the middle of what is a field station, natural area owned by the Claremont colleges collectively. And Pitzer College is one of the 7 Claremont colleges. Sorry, again, click on the trigger. They were looking for, they were launching a new program and new academic program, and they looked to this field station and this building for a place to house the program. And the goals of this project were LEED certification, LEED Gold certification. And they talked about using stretch goals. They wanted, maybe if they do it really well, they'll reach LEED Platinum. And if they did really well, it would be zero net energy certification by ILFI. It's one of the few, if not the only zero net energy certification, certainly the most well known. So these were a stretch goal, and it turned out that they were able to achieve it, as you'll see at the very end. It's not a giant building. Sorry. It's not a giant building. It's only 14,000 square feet, but it's big enough for a project, a good project. It's all 1 story on grade with some basement space. But they were going to make new classrooms, science labs, the studio, collaborative work. In other words, a general classroom building you see in most college campuses is located in Claremont, California, outside of LA. Let's look at the site. So you see a suburban development coming right up to the edge of the field station all around here. And this was the building located on the edge of the field station that they decided they wanted to renovate for this new academic program. If you squint really closely, you can see right here, if you can see my cursor, my arrow, pointing to what looks like a solar or PV array, and it is. And there's one over here, partially blocked by the yellow circle. And we'll get into what those are and why they're there in just a second. But it's surrounded by some trees and so on and so forth, a very natural area. And it has a very historic story to it. So let me just back up a little bit and say that the program, the academic program, is going to be was to be focused on environmental issues, climate resilience, and sustainability. So it's very focused on those green issues, and going to be academic. So it's going to be teaching and research and studies and so forth. It also is going to include outreach to the local K-12 schools, so that kids could come here and learn things about the environment. And also they were going to collaborate with a local indigenous community, which had been occupying this area for quite a long time and was still very active. And this field station was basically unchanged historically. There's a few trails across it and so forth. But they wanted to bring the indigenous community, which has the name Tongva community, into the study of environmental areas with this location. So the program itself was going to be called a conservancy. And this building is actually called the Redford Conservancy at Pitzer College. So it's not just an amorphous academic building. It's got a specific special function, and it's located at Pitzer College. It's located at the field station of Claremont College, but it's Pitzer College's program. And it's called a conservancy because its broad goals were to conserve and protect the ecology of the land where Claremont colleges were first located. So there is this historic aspect of it. In 2015, the college. Let me mention the people and firms involved in this project before I go any further. The college decided to do a feasibility study of locating this program in the building, as I said. Either they were going to put it on this site, either renovating this building right there you see in the site, or to demolish it and put an entirely new building there. So they took the opportunity to evaluate renovation versus new construction, and that's what led them into the embodied carbon study. So the feasibility study was a typical academic feasibility study, involved developing the building program, construction cost estimate, doing energy modeling, and then the new thing was in doing an embodied carbon assessment for the two options to be studied. And the design and planning team, I'll mention their names here. The architects were Carrie Johnson in Los Angeles, and the mechanical engineers and other lighting and so forth was Integral Group in their Los Angeles office. They have several offices, including up here in the Bay Area, but the Los Angeles office was the designers with Carrie Johnson. So the feasibility study was carried out, and the result of, I'll spoil the ending, the result of the study was the decision to renovate the existing building. Not too surprisingly, since you saw the picture of it. And the contract was awarded to the design and construction contract was awarded to the same design and planning team. And the building was finished, renovated, and occupied in December of 2017, essentially 2018. So that was right at the beginning of the embodied carbon assessment tool availability, and Integral Group was kind of paving the way a little bit by taking this on. Let's look at the historic aspect of this, because that's interesting too. So I mentioned it was originally built by the Claremont colleges. It was a student infirmary, and you see an old picture here also what in the same site area, but it was built originally in 1931. You can see the old cars there in front of the old building as a student infirmary and a quarantine area. It's kind of funny to think about that in our pandemic times. It wasn't, 1931 was kind of pre-antibiotic age. And when somebody got sick with something that could be contagious, they moved the students out here to the field station away from Pitzer College and treated them here. So they didn't have it in amongst the rest of the college buildings, but they had it away from the college. And so it was an old infirmary. And it was closed in the 1970s because it was kind of run down. And the city of Claremont did not let the college demolish the building. because it was considered historic by this point, and the college just let it sit, and it gradually fell into decay, and it developed a wildlife of its own living inside. Very funny pictures I saw of the pre-construction was getting the animals out of there. Anyway, the field station itself and the building were in its, let's just say they were in its natural state by the time the design team came to work on it. So here we go with the embodied carbon assessment done by Integral Group. So this is, they looked at the embodied carbon of in the renovation of the building, what was contained herein. And you can see the big chunk here is the floor slabs, the ceilings, and so on. That's basically the concrete. It was a concrete walled structure, so a lot of concrete at the time. And if they renovated the building, they would put solar near the building and be part of the project. And so you can see an entry here for the PV system itself has a certain amount of embodied carbon in it. So this would be the renovation, embodied carbon of the renovated structure. Any additional work on these areas would involve putting a certain amount of concrete and structure and so on in the, and by the way, the assessment energy embodied carbon assessment tool that was used by Integral Group is called one-click LCA, where LCA means life cycle assessment. For those of you, that's the one they recommend. There apparently is the software Tally, which is now built into Revit. One-click LCA, you have to output certain information to this software, and it does a calculation. The engineers like to use this, easier to use and so on. And I think Tally is going through something, so I cannot report on whether that's a second equally good alternative to use for embodied carbon assessment. Some of you probably know more than I about this particular thing about which software to use. But anyway, Integral Group used the one-click LCA software package to develop these numbers. And so let's look at the comparison of the renovation versus the new construction. So there was actually posited what a new building would look like. And you can see the amount of concrete here is the purple block that would have to go into a new building, be new concrete. And going back for a minute to the brown external walls and facade is also a big chunk of a new building here. So it's not much in the renovation because it's already there. And so not much had to be added to the outside and not much had to be added to the structure itself. So the units of this is kilograms of CO2 equivalent to CO2. Most of the time it is CO2, but if you're talking about some other gas that's like CO2, they like to say CO2 equivalent. So the output is in kilograms, and 1,000 kilograms of CO2 is a ton of CO2. So you can see the bottom line here in this graph would be 50 tons of CO2, 100 tons of CO2, and so on and so forth, up to almost 400 tons of CO2. And the renovation it gets to be about 90 tons of CO2 compared to almost 400. So it's clear that there's much smaller carbon footprint for renovation. And given that the building is going to be all electric and not use any fossil fuel, once the grid power is cleaned up, once the grid power is, the grid is cleaned up and it's not carbon, it's totally decarbonized, this will in fact be the carbon footprint of the building. 20 years from now. So we could see that the renovation would be the right choice to make for that from that point of view, and that's essentially what was the influencing factor in decision to go with the renovation. So in the future, it'll be nice if all case studies involved an embodied carbon assessment, and we could see it spelled out so clearly what the options are. So just wanted to show the program accommodation into the existing building. So here is the existing structure, which, as I pointed out, had a lot of interior partitions for hospital rooms and infirmary rooms, and it did not fit at all the program of this new academic program. And so the inside had to be totally cleared out. The animals had to be shooed away, and the building itself on this level, the main level I'm showing here in this floor plan, is only 8,000 square feet, and the program is 14,000. So where did they get the rest of the space? Well, there is some basement space in this, and they renovated a certain amount of basement space and got an additional 2,500 square feet out of the basement. So it is here in the central part. They got some additional space, and the really heavily used teaching spaces are all here on the first level, but they still needed 3,500 square feet more. So they created outdoor classrooms. They decided it would not be restorative to build a new structure or an addition to this building. That would kind of ruin the whole concept. So they decided to use outdoor classrooms under protective canopies. It's a very good climate. So again, and it's in a field station, so it's not surrounded by noisy cars and so on and so forth. So they developed outdoor space for classrooms, and they use them for classrooms. And above the classrooms is where they put the solar panels, because the roof of this structure historically did not have solar panels, obviously. And they did not want to affect the existing building by putting solar panels on it. So the canopy served, the outdoor classrooms served the purpose of the where you put the solar panels and where the additional program space could be found. And we'll look at that in just a minute. We'll look at solar panels on the canopy roofs. And so what's the, we take off the usual design strategies for energy efficiency. You can see how they retrofitted the existing wall. They had to, because the exterior had to be preserved, they had to put the insulation inside. Normally you'd like to put it outside and make use of the thermal mass. But in this case, they just had to put it inside and essentially fur out the walls. They did insulate the roof, the attic space heavily, and put a radiant barrier in there, which increased the U value a lot. And they insulated they had the crawl space, so they were able to insulate the floor in the crawl space as well. So, excuse me, they did a good job insulating. Very interestingly, I wanted to show this for sure. So this is let me go back to the plan here real fast. You see these big classrooms on either side. They cleaned out the interior partitions in these areas, and this is where the big classrooms are. They wanted to daylight these classrooms, and it turns out that the original structure, the infirmary, had some skylights in the roof. So adding the skylight these skylights were removed and covered over later on after World War II. So it was seen to put, if you added skylights, not only would it provide daylighting for the larger spaces, but it would be somewhat restorative. in the original structure itself. So they looked at how to add skylights to the space. And on the left, it shows the 3 different configurations of skylights that they thought about. And on the right, what the daylighting analysis showed for the one of the rooms. One is December 21st at 12 noon and overcast sky. So this is about as dark as you're going to get it during the daytime. And September 21st at 12 noon, a clear sky condition. And you can see, like for option 1, where the skylight is right dead center, you get a bright spot over the middle of the room at 12 noon. And option 2, the light is, well, it's concentrated somewhat at 12 noon, but it does a good job of getting light at either side. And the option 3 was doubling up the number of skylights. They decided it was a little too much light. It was the light quality itself was better in option 2, and so that's what they went for, as it turned out. Yeah, so the best light quality won the day, and adequate light quality most of the time. And they took this option 2 and added skylights to the roof right there. And this is just what it looks like. You can see here in the ceiling of the large classroom what the daylight is like in these spaces. So it's totally renovated into a very nice classroom space. Natural ventilation, well, it turned out that as an infirmary, they were kind of had this idea to be healthy, they would let lots of air in where students were lying sick in bed. And so it's a real advantage, a natural way to take advantage of natural ventilation, especially in a benign climate in this region. So these are all the original windows and doors. And the only thing they replaced was the glass itself because of the historic nature of the building. So they left the window frames alone and just replaced the single glass with the double glazed systems to make it more energy efficient. And you can't see the difference, so that was seen to be okay. Let me see if I have any more comments about this. So obviously you get good cross ventilation, and with the addition of the skylights, they were able to introduce a kind of natural air flow through the space. If the skylights are open, then you get air naturally moving in low through the windows and going up to the skylight where the natural buoyancy of the air is, and the wind blowing by the roof is drawing the air out. So you get really nice airflow through these spaces by just adding those skylights. So that was seen as a real plus. So the fan control units are very typical, like in the school project. It's a ductless fan coil unit tied to a heat pump, very efficient. Just like in the original spec office building, the control system lets the fan coil units operate for heating only when all the user-controlled windows are closed. So if the users open the windows and they're feeling it's a little cold outside and the air is cold, and the heat won't come on unless they shut the windows. So that's something they have to know about. And the student population and occasionally the faculty, they turn over, so they have to be informed about this. But this is what the building is called, conservancy. So that's part of their mission, is that getting informed about how the building works. And the last feature here has to do with the skylights. What they did was that when they took apart the interior walls, it turns out the interior walls are all made with red clay tile, not wood studs or anything. So when they tore them down, they had a lot of broken red clay tile. What they did was they smashed them up and threw them in the crawl space so that the air, when it's being drawn in, can be drawn in through the crawl space, especially at night. So all the windows would be closed for nighttime operation, and the air would be drawn in naturally without any fans by having the skylight open and drawing the air through the crawl space, and there'd be a certain amount of thermal mass there, and the air is making its way out through the skylight. And when people show up in the morning and it's a warm day, they can continue to operate it that way, as long as the thermal mass has got enough coolth in it to cool the air. So kind of free cooling. This has actually got a name. It's called mixed mode ventilation system. You could look that up, get a very clear description about what that is. So there's this added feature, this kind of sophisticated cooling method in a very simple or use of an old structure. And the designer took full advantage of that. So here you are with an outdoor classroom set up with the solar panels on it. This is one of the two of them. I showed you earlier where on the site this was located. So it's this one particular canopy has 52 kilowatt 160 sun power panels. So it not only shows displays what the building is all about, but it's very useful. Obviously, you can't use it very well if it's raining and so on. Anticipating some of the questions here. If it's a driving rainstorm, this outdoor classroom is not being used. But frankly, it's being used primarily by visitors. I mentioned they use it for the local K-12 schools that come and get shown things. And the students are in the program and are taking classes inside the old building, so they're not sitting out here. This is more for use for by outside people. So here we go with the model of energy use. In each case, I just wanted to keep it simple. They did a model of the energy use. This is conditioned area only, so we're not dividing by the gross square feet, not including the area of the outdoor classrooms. So it's not conditioned space. This is the conditioned space inside the old building only. And it was modeled at 21.7 EUI, which is very good. And the actual measurement which was done in the year 2018 to 19, was only 15.8. So it's doing very, very well in terms of performance. They don't have, they have not, the only feedback, post-occupancy feedback, is that they wish they had metered individual loads like heating, how much cooling, how much for lighting. They would like to have they have not metered those individual loads, so only the totals can be given right now. I think this was time to go on to the next slide. I did want to mention that the modeling, I'll mention this after, modeling software is IES VE. The same thing was used on the spec office building. So here we are, the measured, oops, hang on, I'm gonna try to clear this up, what was going on there. That's better. So you can see the solar systems are producing a lot more energy than are being used by the conditioned space. Obviously the building was getting a lot more use in the fall of 2019. No, sorry, this is 2018. So it's 2018, February through February of 2019. So this term, they getting a lot more use. So, but the solar production is going down because it is getting darker, less and less sunlight available. So there was a COVID interruption. So it'll be interesting to see how it's doing now. Whether this pattern is continuing, that they're getting more energy production than energy use. And this is the cumulative. I explained what that is, but again, I like it because net zero is the zero line, and the curve is net positive. So the building is just performing like gangbusters as net positive. And post-production project goals were achieved. They got the certification. They minimized embodied carbon. They met all the programmatic goals. Everyone is very, very happy with the building. I mentioned the user involvement has to be, they have to explain to everybody how the building works in order to optimize the natural ventilation and the heating system operation. And they want to do submetering some more. They may introduce it. Sorry, one more. And the embodied carbon assessment, again, pointing out this project, they did use the analysis, and it did help make decisions, design the decision, the project decisions about renovating the existing building over getting a new building at the site. So with that, I want to last project Q&A and any other final Q&A.
Ed, I think we're out of time. Obviously, there are some questions, but we'll try and get back to some of them after and get some responses to the most pressing ones after, by email, or we'll post them on the website at AIA California. So, so let me pull up my script to just finish this off here. Again, a big thank you to Ed for doing this excellent presentation. And I just want to let you know that if you've made it this far, AIA California staff will submit your attendance for AIA credit. It should appear in your transcript in a few weeks, and then a link to your zero net carbon design mandatory continuing education certificate of completion will also be sent to you. So as always, more resources and tools can be found at the AIA California website, www.aiacalifornia.org/climate action. And then, so again, it's 1:02, so I think we do need to end. So thank you again for joining us today, and we'll see you at our next climate action webinar. Thanks, everyone, and thank you again, Ed.
Okay, thank you, Ben.